Okay, so today we're going to look at the chain rule. We wanted to know the skill in calculating the derivative of a function, basically using this chain rule. Now, students can we'll be successful if we can correctly determine when to use the chain rule and when to apply the chain rule. So the chain rule is dy over dx equals dy over du times du over dx. Let us see how that works. Alright, let us say we've got a function such as this, like y equals x plus 2 all squared. With our understanding, we could expand. We could go square the first, multiply them together and double it, and square the last term. And we could differentiate that. So that becomes 2x plus 4. Okay, that's all very good. But what happens when that power, rather than being to the power of 2, it's the power of 8? Will be there for a while. So we need to find a strategy or a technique to do it quite quickly. And so what we can do, knowing this rule, is what I can do. I'm going to do it first. So first method. I'm going to let whatever's in the inside equal u. Okay, so let u equal x plus 2, whatever's inside the bracket. Okay, now v is then going to be u to the power of 2. Alright, so whatever's in the bracket becomes u. If that's u, then this is all u to the power of 2. If I differentiate, u dash is just going to be 1. Derivative of x is just 1. And v dash is going to be 2u. Okay. And because it's a chain rule, what I'm going to do is just multiply the bottom two things together. So I'm going to get basically dy over dx, we'll say that for the time being, is 2 lots of u. But u is actually x plus 2. Okay? And so we could expand that as well. Again, that would be 2x plus 4, which is what we know. Okay? Or we could have left it at this point. Okay? So that's the first method. Leaving the first thing being u, then this becomes u to the power of 2. Differentiate both sections and multiply the bottom lines together. Okay. The other method, second method, is saying, well, dy over dx is dy over du. So bring the power down. And we're going to multiply it by du of dx, multiplying the derivative of what's in here. And that's just going to be 1, right? We're going to multiply that by 1, and we're going to keep whatever u is. Okay, so it's going to be 2 lots of x plus 2. And that's the second method. Okay, so using the first method, we get, let's say, u equals the inside bit. And that means v is going to be u to the power of 3. If we differentiate each section, the differential of 2x minus 2 is just 2. And this is going to be 3u squared. We're going to multiply those two together. So 2 times 3 is 6. That's going to be u squared, but u is 2x minus 2, and the power changes to 2. Okay. Obviously here we could go in the second method. Okay. So do y over dx, bring the power down, multiply by the derivative or whatever's inside. So at the moment the derivative inside is just 2. And then write down the stuff on the inside. That has not changed. Okay, so 3 times 2 is 6. 2x minus 3. Oh, sorry, that's a 2. Okay, and then obviously bring the power down as well. Okay. Alright. So, if we did the first method, we go u equals x cubed minus 6x, and v equals u negative 3. Differentiate each part. 3 times x, that's 3x squared, minus 6. And this is going to be negative 3u negative 4. Okay, multiply the bottoms. Okay, so we've got negative 3 of all of this, really. So negative 9x squared plus 18. And u is x 3 minus 6x and minus 4. Okay. Otherwise, using the method, we bring down the power, minus 3. We multiply by the derivative of what's inside. So the derivative is 3x squared minus 6. Okay. We keep this and we reduce the power. Alright, so minus 9x squared minus 18 by x cubed minus 6x power negative 4. Alright, when we have something like this, we can rewrite it as 2x minus 7 to the power of a third. Doing the first method, we get u equals 2x minus 7, v equals u to the third, u dash would be 2, v dash would be a third u. A third minus 1 is negative 2/3. Multiply the together, we get dy du is 2/3 of u, which is 2x minus 7, negative 2 over 3. Alright, we can leave that like that. Alternatively, we can go bring the power down, multiply by the derivative, so keep stuff in and then minus the power, which gives us the same solution. Okay. And you can decide which format you would like to use. Okay, thank you.